So our goal on Tuesday was to do all of our individual investigations. I realize some of you may have more investigating that you want to do because you all had questions on your card. But today we're going to have a different focus. We're going to use what you did, wherever your group happens to be, to see if we can prove that these conjectures are actually true. So you have lots of ideas, and now what we're going to do is we're going to try to synthesize what we know and prove it. So I thought that what I would do is start with an example so you would know what it is that actually you're being asked to do. And so I would like you each to I want you to think about a parallelogram, look through your notes, find anything you have written down about what kinds of diagonals guarantee a parallelogram that's not a rectangle and not a rhombus. And then as soon as you've done that, show me that you're ready to talk as a whole class.
Points, so like this, but they can't be perpendicular or parallel, and it makes a parallelogram each time. That's it, right? Wait, if it's like that, what about trapezoids? Isn't it the same thing? Isn't it trapezoid makes...
has to be at the same point and not at the midpoint.
What do you mean? They have to both be like this?
They have to be the same distance from the end point.
Line thing. Like, do you have a roll?
Yeah, I do.
So it's like this, right?
Yeah.
It has to be like at the same, like
hole.
Yeah, the same hole. So then it'll make like a trapezoid.
Oh, okay. But when these both have to be in the middle, though, right? And then, so for parallelogram, it can't be in the middle like that, or parallel, it can be anything else. So that would make it. Anything else would make a parallelogram. Wait, it's both short and long stick, right? Not so it's like short. It's short. Like the pen, yeah. So it's short. Yeah, okay, it's short. Yeah, because if it's like this, I remember if it's like this, then it's a rhombus. If it's like this, it's a rhombus.
So it can't be perpendicular.
Yeah, it can't be perpendicular or parallel. Yeah.
For parallelograms?
Yeah.
Yeah, I said that. I also said that it could be a square or rectangle, so it could be at the center.
Yeah.
Because it'd still be a parallelogram.
Tell you ready.
So the first thing is we are going to write what we've learned as a conjecture. So what we're going to start, we have to make a how is a conjecture formatted? Excuse me? If then. Good. So if. What we're going to end up with is then the figure is a parallelogram. So what we need to do is we need a list of the particular arrangement of diagonals that will create a parallelogram. So can anyone tell us one thing that they believe to be true about the diagonals that would create a parallelogram? All right, I've got 3 hands up. I want everyone to talk to each other. I want you to find the attributes together right now in your group.
A long and short stick fastened at the center.
Well,
what do we know?
It does take one small,
a
small stick and a big stick. So we know it takes that.
Yeah.
Isn't that a 90-degree angle?
No. See, mine's
kind of close to it.
Kind of small. It's kind of off. Yeah. It's a little off. I think if we do it on the back, I'll do it on the back.
If you could.
Square is also a parallelogram, though, so.
Yeah. But, like, let's just do not rhombus or rectangles, whatever.
Now, who thinks that, I'm not going to call on you, I just want to see who thinks you could tell me at least one thing. Tell us at least one thing about the diagonals of a generic parallelogram. You're afraid I'm going to call on you, huh? All right. Good. I've seen these little hands. Come on, get your hands up so I can see, kind of get a sense. All right. It looks like quite a few, and somebody in almost every group. All right. Who's willing to share one thing that the diagonals have to be? All right. And let's hear from Ariel. Okay. If the diagonals and one of the things, let's see, if the diagonals intersect and Ariel, did you mean both of their midpoints?
line A has to intersect with line B's midpoint, and line B has to intersect with line A's midpoint.
Okay. I'll put both of their midpoints. Does anybody know a different way that you might see that in a math book?
Written down?
Huh?
Another way it's written down.
Yeah, in other words, when you're using this language, intersect at both of their midpoints. You know how math books can be kind of hard to figure out exactly what it's saying? So this language we all understand. Edward, do you have an idea?
If the diagonals bisect each other?
Yep, exactly. So that's what you would probably see in a math book. I'm not saying that I want you to write it that way. But what I am saying is that I want you to be familiar with the language that you're going to see in math books. All right. Is that enough to guarantee a parallelogram?
Wait, isn't that? Wait, right. I can't remember.
What's the matter? What, Ryan?
Oh no. I was just being stupid for a second.
You were being what?
Being stupid for a second.
No, you weren't. What do you mean you were being stupid for a second? You had a thought, right?
Yeah.
What was your thought? Tell us what that was. See, the kind of thing that you're doing, though, there's probably people that are thinking, what does that mean? Is that really right? That's not being stupid. That's being smart. Because what you're doing is you're being a skeptic. You're being a skeptic. That's what you need to be. And now that doesn't mean that you're not going to change your mind immediately the minute the words come out of your mouth. That happened to me yesterday when I was talking to two teachers about Algebra 2. And I started to question what they said, and then it was 2 to 1, so I backed down really fast. But then I realized what I said was wrong. And you do feel a little bit stupid. But it's smart. It's really smart to do that, to stick up for your ideas. All right? Okay, is this enough for a parallelogram? All right, Jerry, what else do we need?
And the diagonals cannot be perpendicular.
Okay. And the diagonals cannot be perpendicular. Okay. Is that enough for a generic parallelogram? No? People are saying no? Okay, and we're saying no. What do you think, Dorothy?
The diagonals need to be at different lengths.
Does everyone agree with these things?
Yeah.
And the diagonals need to be different lengths. I'm going to just say are different lengths, okay? When it says and, that means we've got 3 things, 3 criteria that we have to meet in order for our statement to be true. Not one of them, but all 3 of them. Now we have our then statement. Then what? Okay, when we say it's a parallelogram, the figure, and let's actually, I think I'm going to qualify this a little bit and then say then the quadrilateral is a parallelogram. Okay. This is the format of writing your conjectures. And when we're done here, what we're going to be you're going to be writing conjecture for all the shapes that you have worked on so far. All right. Does anybody want to make any different ways of saying something, corrections? Is this okay with everyone? Because I just heard from a few people.